And it's probably that. I'm guessing you guys don't want this to end. Well, guess what? It doesn't have to. You can take me in fall for calculus 1. You take math 154, trigonometry or pre-calc B over the summer. And even if you don't do that and you want more, Mr. Jones, there's YouTube videos up for all the classes. You can always have your share of Mr. Jones. And I always answer emails after, as long as you email me anytime, even after transfer, you got a question, email me, I'll answer questions if you need more Mr. Jones time. But for now, let's get back to what we're doing in this class. So today we're doing 10.1, and 10.1 is on, well, we're introducing the conic sections. And 10.1 focuses on parabolas in specific. So I am going to show you a picture, and I can't freehand this to save my life, to make it look good. So I'm just going to put up this picture, and I'll actually scan it when I scan lecture notes later on. And I'll zoom in on it. If you take a cone, like 2 snow cones, and put them point to point, like we have here, snow cone and snow cone. If you take a plane, like a sharp razor or something, and cut through it at a diagonal, you get something called a parabola, which is what we're doing today. If you cut through it straight up vertically, you get effectively 2 parabolas, one going up and one going down. They look like parabolas, you're not quite. This is called the hyperbola. This will be next Tuesday. And then ellipses we will do on Thursday. Ellipses are if you just do 2 of them at an angle, but it has to intersect both sides of the cone, you get something like that. And circles, obviously, we know what circles look like. We've done circles before. A circle is if the razor goes flat through. An ellipse is if it goes through at an angle, but it still hits both sides. So circle, ellipse, parabola, and hyperbolas go together. You can have them going left or right, or you can have them going up or down. We'll look at both. We can even do parabolas going left or right. Circles look the same up or down, but we can see ellipses going long ways up and down too. We're going to look at all that stuff over the next 8 days. But if you guys are sketching it, I encourage you to try. I'm over here off the fucking screen. It's not even very bright. There we go, that helps a little bit. These are called the conic sections because they come from slicing into a cone. Conic cone. Which is kind of neat. Welcome. This is me not trying to draw it by hand, but everybody else is. So the conic sections come from slicing into cones like that. I'll give you another minute. Talk about some fun definitions for a parabola. You probably never heard a definition for parabola. You just knew what the shape looked like because you've seen it in algebra before. But actually, there's a definition for it. You guys ready? Anyone still drawing it? Okay, so a little bit longer. You guys have seen the Gateway Arch in St. Louis? That tall, like that? It's the bottom half of a hyperbola. It's exactly, it was made off of a mathematical formula. They designed it to match a hyperbola's arch. These come up in a lot of things, as we'll see. All right, so. Question? Okay, zoom back out. All right, so you know how we've been doing the stuff with, like, previously we've seen a times x plus h squared plus k, that kind of jazz. This is old stuff. In fact, it's old stuff related to parabolas. So we have two ways we can write parabolas, and rather than having the k on the right, I'm going to put it on the left. I'm going to put, say, y minus k equals a times x plus h squared. Or not x plus h, x minus h. That's a fail. That's a fail if I ever see one. F for hefe. X minus h. X minus h. This is a parabola that opens upwards, centered at HK. Just the general shape, not like A will change how wide it is, stuff like that. We've seen that before. If A is negative, this is A being positive. If A is negative, it opens downwards. But that's just the up and down parabolas. If, however, the y minus k is squared, let's say we have x minus h equals y minus k squared. This is, oh, let's put a b in front of it. No, I want to stick with A. A is for amplitude or, magnitude kind of thing. Again, we have it centered at HK. But this is a parabola that opens to the right. If A is greater than 0. And it's a parabola that opens to the left if A is less than 0. In fact, if you took the square root of both sides right here, you would see square root of x minus h, and you see our square root shape. We've done square root graphs before. This is just the same thing, but it's a sideways parabola. So let's just take a look at graphing a couple. You're familiar with graphing the ones that go up and down. So let's just do examples of ones that go left to right. Let's graph x minus 4 equals negative y plus 2 squared. So let's match that up with our x minus h equals a times y minus k squared and see what we get. Looks like I'm getting h equals 4, k equals negative 2, and a is negative 1. One, two, three, four, 1, 2. Let's put some other ones up there. I don't know how many y'all need. Easiest way to sketch this is, of course, put a point at our coordinate for negative 2. And look for intercepts. The x-intercept is when y equals 0. So x minus 4 equals negative 2 squared. So x minus 4 equals negative 4. If I add 4 to both sides, I get x equals 0. So my x-intercept is right there. Looks like that's a y-intercept also. This gives me the point 0, 0. If I do my y-intercepts, x equals 0. I have negative 4 equals negative y plus 2 squared. So that's, if I multiply through by a negative, that becomes positive on both sides. And we're going to take the square root. And I get 2 plus or minus 2 equals y plus 2. So we get y equals negative 2 plus or minus 2. That gives us two options, negative 2 plus 2 and negative 2 minus 2. Negative 2 plus 2 is 0. We already know that one, it's right here. So 0, 0. Negative 2 minus 2 is negative 4. We get 0, negative 4, which is right here. I know this is gonna, just like we did for parabolas going up, we would go left to right 1 and up 1, left to right 2 and up 4. The same thing is happening here because a equals negative 1. So I know I got points there. But I didn't even need them. Having the intercepts alone is enough to give me a good idea of what that graph looks like. you can always find these points by, if you plug in y equals -3 and calculate x. Or you could plug in y equals -1 and calculate x there. And just like the vertical parabolas, they are symmetrical about an axis. That's the good thing about parabolas. You really only have to graph half of them, and you get the other half for free if you just do a reflection. Ready for a harder example? Okay. So let's kick it up a notch. We're going to start with x equals 1/2 y squared minus 4y plus 6. We want to write it in the format of the other ones. So what we're going to do is we'll subtract the 6 over. And just so you're see what we're looking for, we're aiming for this. That's our goal. So right now, I have a coefficient in front of y squared. It's the 1/2. I need to factor it out like it would be factored out here. So I'm going to factor out the 1/2. And you do that by effectively dividing everything inside by 1/2. Normally, I would do this process a little bit quicker, but I think it's not intuitive when it's a fraction. -4 divided by 1/2 is the same thing as multiplying by the reciprocal. So I have x minus 6 equals 1/2 y squared minus 8y. Pause and let that sink in. Okay, so we want to be able to write it as something with a minus k. We need a constant here. So what we're going to do is our beloved complete the square. So I'm going to take the -8 divided by 2 and square it. That ends up being -8 divided by 2 is -4. -4 squared is plus 16. So what I have added to the left side or the right side, added to the right now, is not just the 16, but I have a 1/2 times it. 1/2 times 16. Does that make sense? The 16 and the 1/2 here. So I need that's which is 8, right? I've added 8 to the right side by doing this operation right here, completing the square. I need to add 8 to the left side as well. So this puts me right here. If you remember how we completed the square, this is what we dropped into the parentheses. Smack. -4. So this ends up being y plus 4s. No, it's got to be minus. There's no way to get that the other way. Yeah, that just comes straight down. Y minus 4. Now we have it in the format we want. This tells me my h is the opposite sign, -2. And this tells me my k is the opposite sign, which is 4. So and A is positive, A equals 1/2, which means it's going to open to the right. So if you're sketching it, you can kind of get an idea of how you need your graph to look. I need to have -2, and I need a lot of the positive y-axis. I don't even think I used enough positive y-axis. Let's do this. Let's make that a 5, and that's a 5. -2, 4 is right here. Now let's find our intercepts. And we can use either version that we have. If I want to check, if I want my x-intercept, let's see. X-intercept is when y equals 0. I can do that here, or I can do that up here. They should both give us the same thing. Up here, it's telling me right away x equals 6. But let's verify it right here. X plus 2 equals 1/2 times -4 squared. So x plus 2 equals 1/2 of 16. X plus 2 equals 8. X equals 6. So I have an x-intercept of 6, 0, which means I need to add a bunch of shit right here. Bam. I'm going to use some symmetry right now. I know this opens to the right because my A is positive. This should mirror above it, and this one is down 4, so this should be up 4. 1, 2, 3, 4. By symmetry. Now we do our y-intercept. Y-intercept is when x equals 0. This one's probably easier to do with this form right here, so we can take the square root. I've got 2 equals 1/2 y minus 4 squared. So I'm going to multiply by 2 to get rid of the 1/2. And I got 4 equals y minus 4 squared. Take the square root, we get plus or minus 2 equals y minus 4. So y equals 4 plus or minus 2, which is 6 or 2. So 0.6 or 0.2. And we can see that symmetry still holds. It's 2 below this axis and 2 above that axis. Then we just connect the dots. Well, assuming I lined up that bottom a little bit better. I kind of missed the dot. Correct. There we go. Correct. Domain and range here.
-2.
And what kind of notation do I use on it?
You use this bracket around -2
Excellent. What about the range?
and -3.
Oh, look at this. Quick on it. That's correct. All right, you guys ready? All right, so we did a little practice with it. Let's just talk about a generic definition of a parabola, because we're gonna do more stuff. We can break down parabola a little bit more than just showing, points. So a parabola is the set of all points in a plane that is equidistant from a fixed point called the focus, and a fixed line. And this one is called the directrix, which is a great fucking D&D name. I'll tell you that right now. I've used shit like that. I've used directrix. It's a fucking cool name. Even in World of Warcraft, I named my hunter directrix. And in World of Warcraft, we had a pet, and I called the pet Focus. And so my target was always between me and it. No. Yeah. I think I called the pet Focus. No, the pet was Vertex. You'll see. So let's just sketch both versions of this. If we have like, let's see, just a good old y equals x squared. We have a parabola going up. That is the shittiest parabola whatsoever. It is not symmetrical at all. The focus is on the axis of symmetry. And we say for the base version that this is at 0p. And that's my vertex right there. So the focus is E away from the vertex. This holds true when we do left and right also. Then go the exact same distance below it on the other side. And I'm making it dotted because the line isn't really on the graph, but this is the directrix. And if my parabola was better and I had my focus in a better position, some point P of XY, the idea is this is not sketched correctly. But if with the dimensions right, the distance from here to here is D, and the distance from there to there is D. You can see clearly it's not right. I think the way I drew my parabola, I got my P a little too high. I think P should be more like down here and the direction is right here. D should be equal on both. And when you're doing the distance from the point to the directrix, you're doing it so that it makes a right angle. It's perpendicular. You're not just going to any point on the directrix, you're going the shortest route to the directrix. That's the idea. So if it's sketched better, it looks better. So if my base version, my focus is at 0p, my directrix is down p, and this would be the line y equals negative p.
The direction is always gonna be.
If the vertex is at 0, 0,
If it's not at 0.
it's shifted by a k. In this form. So this is a parabola that opens up or down kind of thing. If it opens down, the directrix is on the top half and the focus is on the bottom. So it'd be positive p in that case. But so if we have a parabola with parabola having focus 0p and a directrix y equals negative p, like we do in this picture. It will be in the form x equals 4py. This is effectively true if it opens downward too. If it opens downward, the focus is on the bottom, but it's still 0p, but p will just be negative. So if it opens up, p is greater than 0, and if it opens down, p is less than 0. But this equation still holds true. And I think before we go with the left and right shit, we're just gonna look at like how the fuck do we figure this out? So let's look at an example. X squared equals negative 4y. Which is the same thing. The way you would normally see this is y equals negative 1/4 x squared. That's how we normally look at it. But we're not going to do that here. That would be the normal way of looking at it. To find p, though, this is the way we want it. Because I know this now has to match up with x squared equals 4py. Which means 4p has to equal negative 4. And it means p equals negative 1. And so if I draw this, I hope you guys can see 0, 0 as a point. From either one of these, 0, 0 is a point on the parabola. We haven't done any shifts yet. The focus is going to be at 0, -1. Which is 0, -1. And the directrix is y equals -p, which in this case is y equals +1. And I know it opens downward. And it doesn't open downward like that. Let's see, when x equals 1, y equals -1/4. When x equals 2, y equals -1. So that's my parabola. X squared equals -4y, or y equals -1/4 x squared. And the idea is like the distance from here to here is the same thing as that distance there. And that looks a little bit more. Wait, I did that wrong.
Wait, yeah, I was about to say based on the what you drew above, it'd be the distance to the focus.
There we go. You're right. Fuck, I drew it wrong on all sorts of ways. Amateur hour over here. Yeah, ignore the scribbles.
It's supposed to.
So it should be like the way I did it right here, it should be these. Or if I did it to like over here, let me change colors for this one over here. Let's do like if I did it way down here. Let's call this D2. And these are D1s. But the parabola opens down, we can see the focus is right below it. That's my focus. And that's my directrix.
Isn't it supposed to make a right angle? Is it, or from the focus to the point of the problem to the,
This part is a right angle.
oh, okay. So it doesn't matter on like from the focus to the point of the parabola, if that's
It's,
right.
there's only like 2 ways. No, that's the only time that's gonna be a right angle is if it's directly horizontal or directly above. Everything else is gonna be at an angle, but to the directrix, it'll make a right angle with the directrix. All right, you guys ready for the sideways one? Sideways one is same setup. Instead of doing x squared equals 4py, we switch it around for sideways. It's y squared equals 4px. Usually, which is crazy, I wish they didn't write it in this form. Because a lot of times when we see it, we see like x minus h equals a times y minus k squared kind of thing. So if I were to divide the 4p over, I have x equals 1 over 4p y squared. So the way the a and the 1 over 4, if you have it in this form, the a relates to 1 over 4p. And it does it in the other one too. But that's hard and hell to work with. I always think it's easier to multiply it over and then just say 4p equals this. So let's take a look at an example of this one. So here my focus is at P0 and my directrix is at x equals negative p now. And presumably, if I did this correctly, my sketch looks good. These D's are the same, and it makes a right angle with the directrix. Like that. So the way we would get this, if we were looking at it normally, we would have x equals 1 over 12 y squared. I don't think that's useful. This is in the x minus h equals a times y minus k squared form. So hk is 0, 0 here. But if I want to locate the focus and the directrix, this is much better to get the y squared by itself. So if I multiply by 12, I get 12x equals y squared. And this is the same thing as 4px equals y squared. So I can see that 4p equals 12. So p has to equal 3. My directrix is at x equals negative p. And my focus is at P0, which is 3, 0. My vertex there. I'm just eyeballing it, trying to go, I want to make it the same distance from the focus as to the directrix. That looks about right. That's without calculating any points. And the idea there is I was doing D. In fact, both of these are, since they're vertical like that. And those are about the same length. If we wanted exact points, we could obviously plug in a value for X or Y and find that, making an X and Y table. All right, so you guys ready for more? So let's go the other way. Let's start with information and write an equation. Let's say we know the focus is at 0 3/4. And the vertex is at the origin. Write an equation for this parabola. I think it's helpful to sketch the vertex and focus first. And I don't need them exactly, I just need to see where they are, which axis is where. My vertex is there. My focus is at along the y-axis on the positive side. That's what this problem is telling me. Well, we know when we have the focus, we know the parabola kind of like goes and like surrounds it. So we're going to have something that's like this. Which means this is in the y equals x squared kind of thing. And in that world, with the focus, we had x squared equals 4py. When the x is squared, that was the format. So that parabola, the vertex and focus are telling me the parabola does that. The parabola is telling me we have an x squared because we're opening up and down or opening upwards. And now this gives me my p. This is 0p. So p is 3/4. And I get x squared equals 3y, or y equals 1/3 x squared. Let me give you guys one to try. We'll do the same thing, vertex at origin. And focus is 0, -2. Okay, so if I graph this, I can see my vertex is at the origin. And my focus is below the origin, which means it's opening downward. And if I were just to describe this, I would say this is in the form y equals -x², but it's probably not -x², it's something different. But this tells me that I have x². So we're doing the x² equals 4py again. And I know p is -2. So I get x² equals -ay, or y equals -1/8 x². This is the way we're used to seeing it. This is the way that's most helpful for getting the P. If you start, or you don't have the P to start with. Otherwise, you have to like say. If you start in this form and you don't want to jump over to this form, you have to relate that to 1/4P. So you're saying 1/4P equals -1/8. And you have to kind of solve. This is another way to find P if you don't have it. Which is just only a pain in the ass to work with because it's fractions. I mean, if I cross multiply, why do I have a -8 there? The negative is already out front. Ignore that negative part. I could just cross multiply here. And I get 8 equals -4P. And divide by -4. And I get P equals -2, which we already knew. So if you're trying to find P and you don't want to shift it over to this form, you kind of have to do this. This is a bitch to remember. This is bad enough. Remembering 1/4P and then going, okay, like it takes more, I gotta write it out, I gotta do some cross multiplying. It's harder to do in my head rather than just moving this shit over here, making it so that there's the x squared has nothing in front of it and going 4P, and I know P is -2. I don't even need to write this line normally. I'm just doing that to show me inserting it. I would jump straight to that. Or going the other way, starting here, I would go, okay, that's 4P. I would jump straight to P equals -2 without having to do a bunch of work. Because I can divide this number by 4 pretty easy. That's like math in your head kind of math. But if you like everything like that, you can. I don't recommend it. You're gonna fuck it up. I fuck it up all the time. Anytime there's fractions, you introduce fuck up potential. Right? All right, you guys ready for more? We did that up and down. Let's do some sideways shit. Same thing, we're finding the equation. They might tell you what the axis of symmetry is. That also tells you how it opens, and you don't need to graph it as much. And oh shit, you may not know something. You may just know that it goes through the graph -4, -8. So I don't know what P is here. This is not P. If I'm doing this, the horizontal axis of symmetry, if I do my base equation, I know it's x minus h equals a times y minus k squared. I know I have a y squared here. That's what I'm looking for. That tells me that the 4P is on the x. Horizontal tells me it's opening left or right. It's doing one of those. I don't know, depending on A, if being positive or negative. But I know that's going to be the setup. I don't even know if this is on the axis of symmetry. That may be the vertex, it may not be. I have no idea. But I can take advantage of the fact that I know what x and y are. X is -4 and y is -8. So this gives me 4 times -4 is -16p equals -8 squared is 64. Which means p is 64 over -16, which is -4. Which is just coincidence, is the same thing as the x. So we go back to what we had, 4px equals y squared. And we're gonna take our p and we're gonna plug it in. -16x equals y squared. If you guys want to try. Again, horizontal axis of symmetry. We're gonna do the 0.63. I'll give you 2. And then we'll do a vertical axis of symmetry. Fuck it, let's use -4, 8, -8 again. Changing it up, because we're using a different axis. Fucking hate. They closed the fucking court over here in Tulare. I got fucking jury summons. If you live in Tulare, hey, fuck you. Visalia is by far the closest fucking courthouse. Hell no, bitches. Over to Porterville, I get to fucking go.
I was supposed to go yesterday, they won't find this one.
They didn't last time. Last time I went and sat there. And it was the middle, I don't know when it was. Was it the beginning of the semester or was it last semester? It was hot. It had to be in the beginning of fall. Yeah, I know it's fucking hot outside.
I was actually supposed to go today, but they didn't keep on the before.
Yeah, and they did, last time I went, I didn't get canceled. I got called in. And I went in and like, I think it was like the week before school started. When they had it, I'm sure it was like August 7th or some shit like that. And I went in and I was just like, yeah, I can serve jury duty if this shit's done in a week. Otherwise, my students are screwed. I don't mind doing jury duty. I really don't. I actually find it fascinating. I don't want to do it over fucking Porterville though. All right. Did you guys do this? All right, so horizontal tells me that it's going left and right, and it looks like it's going in the right direction like that. This is an x equals y squared kind of thing. So I'm gonna have 4px equals y squared. And I will plug in my values. I've got 4p times 6 equals y squared is 3 squared. Damn, I chose shitty values. It's fucking delightful. This is what happens when you just make shit up. 24p equals 9. So p equals 9 over 24. Well, that's not too bad. So if I plug it in, I've got 4 times 9 over 24, x equals y squared. And I know this was 6 times 4 because that's how I got it. So I cancel out a 4. I get 9 over 6, x equals y squared, or 3/2 x equals y squared. If I go up and down, vertical axis tells me, and it's the point is below the x-axis, tells me it's opening downward because I got a vertical axis. So that is the x squared, the x is squared on that part. So I'm going to have a 4py equals x squared. And we'll do the same shit. 4p times -8 equals -4 squared. So -32p equals 16. And p equals 16 over -32, which is -1/2. I plug that in. And I get -2y equals x squared. You guys ready for more? I see some pins still moving. I'll be patient. Wait for it. Stay on target. Oh, not only did it do that, my jury summons is May the 22nd, May the 23rd. It's literally fucking finals week. And they just so happen to, they don't know it. But I'm doing I have a final from 3 to 5 on that day, but I'm doing it like the week before. Like the day before finals week start, so that they don't have to come in, so I can technically still do it. I'd rather go, it's like on a Tuesday, I'd rather go on, if there's something on Tuesday, it generally gets canceled. Oh, fucking more, yeah. Quick rant about fucking Porterville jury duty. So last time, this is what I fucking forgot, this is what happened last time. It was that week before school started, it was fucking hard and fuck. They call us out there Monday morning. Was it Monday morning, or was it 8:30? Yeah, I wanna say. They called us out there at 8:30. Fucking gay like by 11. No, they made us go to lunch first and come back, I remember, because it's fucking mad and shit. They tend to have like everybody take like a lunch at like 10 fucking 30, 11, come like an hour lunch, come back. I didn't get assigned a jury thing until like 1 o'clock, and then they're like, come back tomorrow. It was literally like 15 minutes after the lunch break ended, and they had done most of them by then. Like no one was left in the room. I'm like, motherfuckers. Why don't we do this beforehand? And why don't we actually start jury duty today? Like, it's 1 o'clock. We got 4 hours. We can start doing the jury selection process. You making me fucking drive out here twice. I was mad. I'm not fucking be mad again in May. Or in fucking 3 weeks, I'm gonna be mad. All right. Enough of that. So, all the stuff we've been doing with the P has been with the vertex at 0, 0. If the vertex is at HK. How does this change? The x squared equals 4py transitions into x minus h squared equals 4p times y minus k. So you're literally, and this is going to happen in both of them. Notice we replaced, x got replaced with x minus h, y got replaced with y minus k. That's going to happen in the other one as well. If I have y squared equals 4px, this is going to turn into y minus k squared equals 4p times x minus h. Yeah.
So the X's are always gonna be with the H.
Oh, yeah, yeah. Because that's the way I described it here. H is, if I had put K comma H, it'd be the other way around. Good question. So, the X is squared here, the Y is squared here. The thing in here gives the axis of symmetry. Is inside the square. Set it equal to 0. So for this one, x equals h is the axis of symmetry. I'm going to call it AOS. And if I do this one right here, so I got x minus h equals 0, y minus k equals 0, y equals k is the axis of symmetry there. And just remember, the focus is at a distance. I would say P, but since I'm using distance, it needs to be positive. So we'll say absolute value of P from the vertex. So let's say the vertex is at -2, 3. The focus is at -2, 2. Let's write the equation. Let's graph it and give domain and range. So what are we gonna do? Let's put some points on the graph. Let's figure out some shit, see what's going on. I think I can see a little bit better what's going on if I graph it. So I've got my vertex is at -2, 3. And my focus is at -2, 2. Which tells me it's going to open downward. And if it's opening downward, then the x is the squared thing here. And I need to use the x minus h squared one. I have h. H is -2, so this turns into +2 squared. And I have k is 3. I got y minus 3. What about p? Focus is at a distance p from the vertex. How far away is that? 1. That's 1 away, so p is going to be 1. So 4 times 1 is just 4. But is it 1? It's downward. I gotta make it -1. P is -1. Which means that's going to be -4. Okay, so now that we have that, if let's see, let's multiply it out somehow. This is y minus 3 equals -1/4 x plus 2 squared. If I want to find intercepts to graph this, I could do the y-intercepts are when x equals 0. And I got y minus 3 equals -1/4 times 2 squared. So that's -1/4 times 4 is -1. Y minus 3 equals -1. So y equals 2. I have a point at 0, 2. Now I wish I hadn't wrote my p equals 1 right there because it's in my fucking way. This is down 1 and over 2. By symmetry, I can go down 1 and over 2 to the left. And put a point there. And we should find our x-intercepts when y equals 0. I have -3 equals -1/4 x plus 2 squared. This is going to be shitty. So if I multiply by -1/4, I get 12 equals x plus 2 squared. Which means x plus 2, if I take the square root of both sides, is plus or minus the square root of 12. So x equals -2 plus or minus the square root of 12. I'm going to estimate this. Square root of 9 is 3. Square root of 16 is 4. 12 is a little bit closer to 3 than 4, or to 9 rather than 16. So I'm going to say this is probably a little bit below half. This is approximate. I'm guessing here. I don't want to get a calculator out, but I can do -2 plus or minus 3.4 and get sort of decent dots on the graph. -2 plus would be 1.4. And -2 minus 3.4 is -5.4. So I gotta go 2 left over here and put this right there. You guys ready for more? You guys ready to try one without my help? Actually, before we do, I'm going to point out where do parabolas show up in real life? Headlights are parabolic dishes where the lamp is the focus. And it just so happens with having the lamp at the focus, there's my little light bulb, that no matter which way the light emits from, it reflects the same direction. All pointing forward. So headlights are like this. Satellite dishes. Satellite dishes do this too. Things like that. All right, let me give you a problem. Same thing, we're gonna have the vertex is at 1, 3. The focus is at -1, 3. Do the equation. Graph it. We didn't do domain and range last time, did we? Let's pull that back out. Okay. I can see from the graph, the domain is all numbers. And the range starts at -infinity and goes up to the vertex, which is at 3. All right, let's take a look at the graph. I got a vertex here. And my focus is here. Which means the graph is opening left. Which means I'm in the form. The squared thing has got to be y. So I've got x minus h equals 4p. Oh, 4p goes over here. Times y minus k squared. P is what? How far apart are these two? They're 2 apart, so the distance is 2. And it's going to the left from the vertex. So P is -2. So we have what we need to fill in. 4 times -2 times x minus 1, which is my h, equals y minus 3, which is my k squared. So I put the y minus 3 squared on the left, y minus 3 squared equals -8 times x minus 1. All right, graphing it. When x equals 0, we get y minus 3 squared equals -8 times -1, which is +8. If I take the square root, I get y minus 3 equals plus or minus the square root of 8. Square root of 8 is pretty close to square root of 9, but it's just below it. I'm guessing we're going to end up with something. Well, I know we end up with 3 equals plus or minus square root of 8. But square root of 8 should be approximately, I'm going to guess like, I don't know, 2.7 or so. I just need to get close to it on the graph. So 3 plus or minus 2.7 is going to be y equals 5.7 or 0.3 when x equals 0. So, of course, I did a shitty job giving me some options here. 5.7 and 0.3. So I was doing something like this. If I do y equals 0, I get -3 squared equals -8x plus 8. So 9 equals -8x plus 8. I subtract 8, I get 1 equals -8x. So x equals -1/8. -180. Which we could see was going to be pretty close to the origin just by the way the graph was looking. We have our equation here, we graphed it. What's the domain on this? What? What kind of? What about a range? It's all real numbers, yeah. So we'd either write all real numbers or we could write -∞ to infinity. And there we go. that is today's lecture brought to you by DirecTV. And have a good day. When you're done riding, get the fuck out. Thank you.